Title this Solving Nonlinear Systems. Okay, I'm not going to go through this example, but I'll use this as a talking point. So if I have a linear versus a quadratic, how we solve these algebraically. In the conversations, what's the first thing I got to do? Move everything to one side. That's correct. All right. All variables and constants are all on one side of an equation. Okay, so that's the prompting I give you, that when we are solving these, it has to be equal to 0 first. That's the closest I could give you or try to prompt you into thinking about on a test. Very closest. Second thing I have to do. So for instance, on this one, I'd have to subtract 2x and subtract 1. So I'd have 2x squared minus 4x. Oops. Equals 0. Okay, what are the tools we have to solving quadratics? Yep, use quadratic formula. Or what? Or factor, yes. To solve for x. All right, so this is an example of that, and this is pretty easy factoring. This is from Math 1. What do these both share? 2 and an x. So left inside my parentheses is what? Yep, x and negative 2. When we get our two factors, we set those equal to 0. To find what our x values are. That should be familiar. This is supposed to be written down. I don't know. Be prepared. All right, we have x. What's left? Yep. Plug x back in to your original equation. To find y. So of this, which of these is an easier equation of that system? The first one, I would agree. So y equals 2x plus 1, right? If I plug 0 in, I get 1 as a result. So my first solution is 0, 1. I do this again, y equals 2 times the other x value, 2, and that'll give me 5. So my other solution point is 2, 5. Okay, you got to remember, we treat these as a system of equations. In this case, a linear and a quadratic, but the investigation before this, we did linear equations versus inverse equations. So if instead you had 2x plus 1 equal to 4 over x, or something like that. So you also have to be prepared for the linear versus your inverse equation. All right, now we're going to switch gears a little bit. We're going to talk about the potential situations. All right, we could have with our quadratic in the conversation, what was one of the potential solutions for a quadratic versus a linear? 2 solutions, okay, so I could draw my parabola, and I would have to have 2 intersection points. So this would be 2 solutions. What's another possibility? 1 solution, okay. Now this is a little bit harder to do. It has to just have a glance off of the side. One solution. And what's the other? No. And no solutions. So what would that look like? Where would the line be? Anywhere it doesn't hit, correct. We also had these for inverses. What would the 2 solutions look like in this case? Going through both, yeah. Now there are more ways that you could have 2 solutions. The big idea, they intersect. Okay, let's say we have 1 solution. Once again, we have a glancing hit off the side. And then I would say for these inverses, no solutions is pretty easy to picture. I think one of you in here talked about that making a sandwich. I don't know. Someone said it looked like a sandwich. Maybe? Yeah, I don't... Oh, well, maybe a line butter sandwich between a butterfly? I don't know. Could be. All right, now, if you have no solutions, algebraically speaking, specifically with no solutions, what's that going to look like if we try to factor and there's no solutions? Okay, can't be factored. What's that going to look like with quadratic formula?
Negative b squared minus 4ac is negative.
So you'll end up with a negative square root. Any questions?